Hello and welcome back to Mech Zone. In the previous lecture, we have started off with this problem which was asked in IES, and we shall be doing this. All the data that has been given, I have already noted it down. Just one data was left, that is mass of the reciprocating part has been given to us as 120 kg, and we have also been given that assuming the load is constant, we have been given that load is constant. So load is constant simply means that we are having T mean as constant. So this is one data that we have been given, and all the other data have been given also. So first we will do we will try to find out the value of omega, that is 2 pi n upon 60, and it is 2 into pi into 250 upon 60. From here we will get the value of omega in radians per second. Okay, now what we will do is we will first try to find out the cycle of the function. So in the function we have been given as sine 2 theta and cos 2 theta. Now I will discuss how to find out the cycle of the circle, and I will give you some glimpses of your class 11th and 12th about the periods of the function. Period of functions: for sine theta the period was 2 pi, for cos theta the period was also 2 pi, tan theta the period was pi, and if we have say sine 3 theta, it is equals to 2 pi by 3. So 3 theta है तो 2 pi को 3 से divide कर दिया. Cos 3 theta, then the period is 2 pi by 3, and if we have tan 7 theta, it is equals to pi by 7. Okay, now what has been given is, if the function is given as a combination, say example sine 3 theta 1000 sine 3 theta plus 3000 cos 5 theta, what we will do is add plus 900 tan 7 theta. Now we have been given three angles, that is sine theta, cos 5 theta and tan 7 theta. So we will write down the individual periods, that is for this we have 2 pi by 3, for this we have 2 pi by 5, and for this we have pi by 7. So what we will do is we will take the numerator का LCM of the numerators, इसका ये हो गया 1 pi, and we will take the HCF of the denominators. Now LCM of 2, 2 and 1 is simply 2, and pi तो लग ही जाएगा, and HCF of the denominator is actually 1. So period of the function, this entire function simply becomes 2 pi upon 1, that is 2 pi. So how we have obtained it is by taking the LCM of numerator upon the HCF of denominator. Okay, so this is how we are going to find out the function. So for this we see that the period for this is 2 pi upon 2 pi, that is 2 pi upon 2, that is pi, and for this also we will find the period is pi. So LCM upon HCF will simply give us pi. So the function is having the period as pi, so that means it is varying between 0 to pi. Now since we know that the cycle of function is actually pi and it is varying between 0 to pi, so the W cycle, as I have already told you, can be evaluated by means of integration, and we will integrate this given equation or this function from 0 to pi, that is 0 to pi T d theta. So from here we will find out the value of the W cycle, and when you will solve it you will be getting 10,000 pi joules. This is 10,000 pi joules. So the first thing, that is power is equals to torque into omega, and here both the values should be mean values, and T mean is actually equals to W cycle upon pi, which was the cycle period. So this is 10,000 pi upon pi, so this becomes 10,000 joules. Okay, T mean has been given as 10,000 joules, and omega we have already calculated, so we will have 10,000 multiplied by 2 pi by 60 into 250. So from this we will find out the value of power. Now the second one was, we have the moment of inertia. Now in order to find out the moment of inertia, we first have to plot the curve. And we will find those points where the T line cuts T mean line. So we have to find those points. Okay, so all those points would be can be find out by 10,000 plus 2,000 sine 2 theta minus 1800 cos 2 theta. This would be equal to 10,000. This is actually the value of T mean. Okay, and this was the value of T. So यहाँ से हमारा जब हम इसे solve करेंगे तो we will get tan 2 theta is equals to 0.9 such that 2 theta is equals to 41.9872 degree or 221.9872 degree or 401.9872 degree and so on. So hence the theta becomes 20.9936 degree and 110.9936 degree. Why? We are taking only these two values because we have to take the values between 0 to pi, which was the period of the function. So now we will plot the curve and we will see that this is T, say this is T mean and is equals to 10,000. वैसे गेट में इतना भारी सवाल ये पोर्शन नहीं पूछा जाएगा, पावर तक का पूछा जा सकता है. एंड okay, this is negative, this is positive, this is negative, and this is corresponding to 20.9936 degree and this is corresponding to 110.9936 degree. So at 0 degree T is actually less than 10,000 joules. So delta E max can be simply calculated by taking this area. I have already told you that evaluate this area equal to delta E max. So delta E max would be 20.9936 से लेके 100 पेन खत्म हो गई. Just a second. पेन बड़ी जल्दी खत्म हो जाने में क्या बात है. चलिए, so 110.9936 T minus T mean d theta. Okay, this is equals to I omega square CS. ये किसके बराबर हो जाएगा? I omega square CS. And from here we will find out the value of I. Okay, from here we will find out the value of I. Now from the diagram we know that T minus T mean at theta is, so T minus T mean at theta is equals to 45 degree. It is simply equal to I into alpha. So 2000, it is equals to, when we will find this term, this we find that this is equals to 2000 and this is equals to I into alpha. So 2000 upon I would be equal to alpha and the unit would be radians per second square. Okay, so this was the problem that has been asked in IES. Okay, now what we will do is we will start with the new topic, that is requirement of flywheel in multi-cylinder engines. So this is one of the very important and very interesting concepts, that is requirement of flywheel in a multi-cylinder engine. Now multi-cylinder engine concept came into picture mainly to increase the power as well as to increase the uniformity of power. मतलब सिर्फ power को ही नहीं लेकिन power की uniformity को भी increase करने के लिए we used multi-cylinder engines so that the fluctuation in case of the engines can be decreased and the requirement of the flywheel can also be suppressed up to a certain limit. So this is achieved by imposing a very nice concept which is known as the firing order. Okay, So this concept is also playing a very important role in the area of balancing, and we will be studying about this topic in balancing chapter. Okay, now I will draw the diagram for a multi-cylinder engine. So some of the areas or some of the curves are lying above, so hence they are indicated by plus sign, and some which are indicated below the mean torque line, they are actually represented by the minus line. And from O to the point M, we are actually having the cycle of the system. And for example, this area has been given as 1.5, this has been given as 2, this has been given as 1, say this has been given as 1.5, this is 2, this is 0.5, this is 1, this is 1, this is again 1, and this has been given by 2, and this has been given by 1. And we have been given energy at A is equals to E, and this is a known quantity. Now if we wish to write down the energy at B, it would be simply, and this is actually equals to 1, so energy at B would be equals to energy at A plus 1. Okay, so sorry, plus 1, this simply becomes E plus 1. Now say in the same manner we are going to find out the energy at C. So energy at C would be plus 1 minus 1.5, so net becomes E minus 0.5. Similarly, energy at D would be plus 1 plus 2, that is plus 3, and plus 3 minus 1.5 is 1.5, so E plus 1.5. So in the same way we can write down the energy at the different points in case of the diagram when we are drawing for the multi-cylinder engine. Okay, so and we will see that E max can also be found out, and E max is actually occurring at the point F, and E minimum can also be found out, which is occurring at the point K. So at F, the energy maximum would be E plus 2, and minimum energy is E minus 1. So E max would be corresponding to N max, and E min would be corresponding to N minimum. So delta E maximum would be E plus 2 minus E minus 1. This is simply equals to 3 mm square. Actually these digits 2, 1, 1.5, they are actually mm square. That means the area of these portions have been given to us. For example, in the question, if the scale has been taken as 1 mm square is equals to 0.06 joule. So sometimes horizontal and vertical scales may be given separately, so we multiply them together to get the scale of area. So horizontal scale multiplied by the vertical scale, and we will get the scale of area. Okay, so this is an important topic or important point which needs to be remembered while solving the numericals. Now we will discuss about the requirement of a flywheel in power presses. Requirement of flywheel in power presses. Okay, so these presses are actually used for metal forming process, and they require a driving body, that is a motor, and the motor is actually related to two components. One of them is cam and the other one is crank, and in the cam we have a follower which is actually punch here in this case, and the crank is actually the piston which is also acting as a punch. So requirement of flywheel in the power press. Now what we will do is we will discuss some numerical data corresponding to this. or numerical aspect, say one cycle of power press. If we are talking about one cycle of power press, say this is the punch, okay, and the punch is coming from here to here. This is the depth of the surface. So it is first coming here and then it is penetrating down and again it has to go up. So the time taken to complete one cycle is जब यहाँ से पूरा नीचे जाएगा और नीचे से पूरा ऊपर आएगा, that would be called as one cycle, and the time corresponding to one cycle is called as cycle time. Okay, but the actual operation time is very very much less than the cycle time. Operation कहाँ से कहाँ हो रहा है? सिर्फ इतने ही region में operation हो रहा है. So operation time is actually very very less as compared to the cycle time, and it is nearly 1/4. तो operation time cycle time का nearly 1/4 होता है. And in case of in one cycle the crank rotation is actually 2 pi, but the cam rotation is actually less than or equals to 2 pi, and simply because it is having some due to dwell period. Okay, due to dwell period. Now what I will do is I will solve one very 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 important problem, and you have to look at that problem because वो काफ़ी ज़्यादा हमारी important है और कई सारे हमारे concepts clear भी हो जाएंगे. So I will write down a problem. I will simply write down a data. Okay, so okay, we have been given that a punching press is desired to punch 720 holes per hour such that the diameter of the hole has been given as 2 mm and the thickness of the sheet has been given as 3 mm. And energy which is required for 1 mm of square area is about 20 joules, and operation time has been given as 1/4 seconds, and it is observed that during operation the speed of the flywheel is actually getting decreased from 100 to 80 rpm, and we have to find out the mass of the flywheel such that the radius of gyration has been given as 30 centimeter. Now we see that 720 holes per hour, and 1 hour has 3600 seconds, so we can write 720 holes per 3600 seconds. So we can say that it is actually 1 hole in 5 seconds, or 720 holes 3600 second. 1 hole would be 3600 upon 720, so it is coming out to be 5 seconds. So 1 hole is done in 5 seconds. That means we have been given cycle time is equals to 5 seconds. We have been given the cycle time as 5 seconds. Okay, now punching time or operation time, punching time has been given as 1/4 second. Okay, this has been given as 1/4 second, which I already told you. Now if we look at the hole, if this hole has to be sheared in a thickness, in a sheet of thickness say 3 mm, this would actually be 3 mm, and the diameter has been given as 2 mm. So area, now the area which has to be sheared is this area, and this area is simply nothing but the curved area, that is pi dt. So it is pi into d means 3 and t, d means 2 and t means 3. It is equals to 6 pi mm square. Okay, 6 pi mm square, and we know that 20 joule of energy is required for 1 mm square. So how much energy would be required for 6 mm square? It would be for 6 pi mm square, energy total required would be 20 into 6 pi, and it is equals to 120 pi joules. Okay, so this much amount of energy would be required for the given problem. Now what we know is power is simple energy or work upon time. So an energy would be what? Energy would be energy of whole of or one whole into number of holes per second. So energy has been given as 120 pi into a number of holes per second. How many number of holes per second were there? 1 upon 5. We had 1 upon 5. So this is actually coming out to be 24 pi watt. Okay, so this power is coming out to be 24 pi watt, and this power which have been calculated is actually the power of the motor. Okay, it has been the power of the motor. Now since the speed was decreased from 100 rpm to 80 rpm, so omega average would be 100 plus 80 upon 2, and this is, we can calculate, and CS would be 100 minus 80 upon omega mean. We can also find out this parameter. Now if we consider only the punching portion, in case of the punching portion, time required is only 1 upon 4th of a second. So E available would be simply 24 pi into 1 upon 4, that is 6 pi joules, and we know that energy of the whole was 120 pi joules. So what would be the deficient or the fluctuation of energy? The fluctuation of energy is 120 minus 6 pi, this is equals to I omega square CS, where this actually omega should be the average value and I should be written as mk square, and m has to be determined, k is given, and this would be actually corresponding to the amount of energy to be supplied by flywheel. Okay, to be supplied by flywheel. So by solving this we will get the answer. Now you must be wondering why the power of the motor is always calculated by means of the cycle time and not by the operation time. This question was asked in one of the interviews, and the answer to this question is it is not calculated by means of operation time but calculated on the basis of cycle time, because अगर हमने ऑपरेशन टाइम के बेसिस पे कैलकुलेट कर दिया तो कॉस्ट ऑफ इलेक्ट्रिसिटी जो बिल आएगा दैट वुड बी वेरी वेरी हाई, इसीलिए हम लोग हमेशा उसे साइकिल टाइम से ऑपरेट करते हैं, ना कि अपने ऑपरेशन टाइम से. ओके, नाउ वी कम टू द लास्ट पोर्शन ऑफ दिस चैप्टर, दैट इज द डिजाइनिंग ऑफ flywheel rim. Designing of the flywheel rim. Rim is actually where the mass is concentrated on the periphery. Actually आज थोड़ी आवाज़ मेरी गड़बड़ है तो गले में थोड़ा सा दिक्कत है, बट स्टिल कोई बात नहीं है. तो चलिए, ये हो गया हमारा ring where most of the mass is concentrated on the periphery, and this is actually rotating at an angular velocity omega such that it is having a radius equal to r, and we will consider a differential element of this ring such that this angle is d theta. Okay, now we will draw the free body diagram of this elemental portion such that, okay, this angle is d theta by 2, this is angle is also d theta by 2, this is dm r omega square. So this would be the centrifugal force, this is the centrifugal force, and this is actually d theta by 2, this is actually d theta by 2, and the tension would be acting in this direction. Omega is like this. So if we consider A as the rim cross section area, so Now we will write down the equilibrium equation, and we have 2t sine d theta by 2 is equals to dm r omega square. So 2t into d theta by 2, since this angle is small, so sine theta is nearly equals to theta. This is equals to dm r omega square, and m is equals to r d theta a into rho, that is mass is equals to density into volume. So we write 2d into d theta by 2, and instead of dm we write r d theta a into rho r omega square. So t upon a, this is rho r omega square, r omega whole square, or rho v square. So this actually t by a is nothing but it is the hoop or circumferential stress, hoop or circumferential stress. And now we will find out the value of v. So v is equals to r omega, or it is equals to under root sigma by rho. This is a very important formula, and many questions have been asked directly based on this formula. So this is actually where sigma is the hoop stress developed, hoop stress developed, or it is also called as the centrifugal stress, centrifugal stress. Okay, if sigma b is the bearing stress of the ring material such that sigma should be less than or equals to sigma b, and v max would be equals to under root sigma b upon rho, where rho is actually the density of the material. Okay, where rho is actually the density of the material. So if we are using this flywheel at medium speeds, if we are using the flywheel at medium speeds, then the flywheel is actually comprising of this spokes. Okay, it is comprising of spokes. But when we are talking about at high speeds, we are going to use the disc shaped flywheel. So in case of the disc shaped flywheel, this is actually the best type of flywheel, since I is less than mr square, or in some case it is greater than mr square by 2. In case of the ring and in case of the disc, we have derived these different formulas such that if we wish to find out the diagrammatic representation of the stress, so we would obtain stress variation is somehow like this, and it is 0 at the center. So thinner at the center but thicker at the periphery. So it is thinner at the center and thicker at the periphery. So with this we come to the end of this chapter on flywheels, and in the next lecture we shall be starting with another important topic, and that is we shall be starting with another topic that is balancing. Okay, so I hope you people are enjoying our lectures. So do give us your valuable feedbacks and also subscribe to our channel. आप अपने friends और colleagues को भी हमारे channel के बारे में बताइए, so that they are also benefited, because everything is available absolutely free of cost on our channel. तो हमें अपने valuable feedbacks देते रहिए, हमारे lectures को view करते रहिए और हमारे साथ अपनी problems को भी share कीजिए. So thank you so much.